Hello, this is Gunasekaran, Assistant Professor of Mechanical Engineering at SNS College of Engineering. Now we are seeing about measurement and analysis of thermal stress. Okay. Measurement and analysis of thermal stress. It involves experimental techniques like strain gauge, thermal imaging and thermoelastic stress analysis. Finite element analysis FEA means is commonly used for numerical simulation. Okay. Understood? Thermal properties and boundary conditions aids in accurate management of thermal stresses in engineering system. Okay, here high precision instrument data accuracy and also used for advanced analytical technique interpreting complex data. Okay, mitigation and prevention of thermal stresses. It involves several stages like material selection, design modifications and thermal barrier coatings. Material selection, choosing a material with how thermal expansion coefficient, and design also adapting structural to minimize temperature, and thermal barriers means implementing a productive layers to mitigate temperature induced effects. That means materials with compatible coefficient of thermal expansion and designing structural with expansion joined to accommodate thermal movement, and incorrecting thermal insulation to minimize temperature differential. Optimization of component geometry and employing thermal barrier further reduce thermal stress effects. Monitoring and controlling operating temperatures as well as implementing cooling or heating system can also mitigate thermal stress. Additionally, predictive modeling through finite element analysis, okay, in identifying potential stress concentrations, enabling productive design modifications to preventing thermal stress induced failure. Okay, note to prevent thermal stress induced failure and ensure the longevity and reliability of engineering system. Okay, case study of thermal stress failure. Structural component, here pipeline and heat exchanger. Structural component material, steel, copper alloy, and failure mode, cracking due to thermal cycling, leakage from stress, corrosion, cracking. Example 1. Case study of thermal stress failure involved the Tokomo narrow bridge which collapsed due to wind induced oscillation by thermal stresses. Another example is the failure of spacecraft thermal protection system during re-entry due to differential heating leading to structural damage. This incident underscore the importance of considering thermal stress in engineering design due to prevent failure and ensure the safety of reliability of infrastructure and aerospace system. Okay, application of thermal stresses, including designing thermal barrier for spacecraft re-entry, optimizing material for high temperature environment like turbine engines, and engineering thermal management system for electronics to prevent overheating. Okay. Note, understanding managing thermal stresses are crucial in ensuring the reliability and performance of various technological system. Okay, thank you.